Let's take a look at a binomial expansion. Now, the binomial expansion formula allows us to take a binomial by two terms, raised to some exponent, and it allows us to take this expression and expand it out into a polynomial without having to do the work of all the multiplication. While the binomial formula itself is a little bit intimidating, it's really full of patterns, and if you can become comfortable and recognize the patterns, I think that you will find this quite handy. So the first thing we have to do is identify the information that we have, because in the binomial expansion, each term of our expansion is going to have a coefficient, an A term, and a B term. So let's identify A. A is equal to 5x. Now our B term. B is equal to -1. And the other key piece of information we need to identify is the exponent here, or 3, which we're going to refer to as n. So now, as I said, each term in our expansion is going to have 3 pieces of information. It's going to have a coefficient, it's going to have the A term, and it's going to have the B piece of information. So let's put our coefficients in. In our first term, the coefficient, we can notate it by the n, which is our 3. And now in the bottom here is the 0. This is not a fraction. It's the notation for a binomial coefficient. Notice no fraction bar there. It's 3 over 0. So now let's work with our patterns. There's the coefficient for our first term. For our second term, our coefficient is going to be notated 3 over 1. For our third term, it's going to be 3 over 2. And for our fourth term, it's 3 over 3. And now we're done. As soon as the number on top, n, is the same as the number on the bottom, the 3 over 3, we're done. So we have our coefficients laid out for each term. Now let's take a look at our A information. In our first term, we have our A information, and now the exponent that corresponds to this first term for A is the n, our largest exponent, which is the 3. In our next term, there is our 5x, and now the exponent decreases by 1, so we go 5x squared. In the next term, there's our A, 5x to the 1. Now, you don't have to write the 1 in. 5x to the 1 is 5x, but I'm writing that in so that we can see how the pattern proceeds, that it decreases by 1. In this last term, we will never see that A component. It will always have disappeared, but we can show it by 5x to the 0, because anything to the 0 power is just 1. So it's not there, but we can show it by the exponent of 0. So we have our coefficients, we have our A's. Now we have to put in the third piece of information that every term has, which is our B term. In the first term, there is no B. We don't see it. It's disappeared. Just like this has disappeared in the last term, B has disappeared here. But we can denote that by -1 to the 0 power. Again, anything to the 0 power is just 1. In our next term, we have our B term, and now this exponent is going to be increasing by 1. So now we're at 1, and then here we're at -1 to the power of 2, and then here we're at -1 to the power of 3. So notice the pattern. A decreases, the exponent decreases, starts out the biggest it can, and decreases by 1 till it disappears. Our B is disappeared in our first term, and then its exponent increases by 1 in each subsequent term until in the last term it's as big as it's going to get. So this is looking kind of Christmassy here, and also it's sort of run on. So let me put in the plus signs so we can see our individual terms. First term, second term, third term, fourth term. So now that we've laid out the information using our patterns, it's time to start to evaluate. And you can evaluate this in a couple of different ways, however you feel comfortable in evaluating coefficients first or the terms first. I'm going to deal with the coefficients first. And each of these coefficients, you can find them either by using the calculator, or you can use the formula to expand them, or you can use the coefficients from Pascal's triangle. So I'm going to use from Pascal's triangle, which is in the first term, it's always 1, and the last term is always 1. So whenever the denominator, the bottom is 0, it's 1, and whenever these two numbers are the same, it's 1. Now here, this term is going to be, this coefficient is going to be 3, and this coefficient is going to be 3. So our coefficients are 1, 3, 3, 1. And as I said, I know them from Pascal's triangle. If you need more help on that, you can see me or see another video on that. So there's our coefficients. Now we need to start evaluating our A and B terms. So let's take a look at this first one here, 5x cubed. Notice the parentheses, and parentheses will be your friends here. I highly encourage you, whenever you're laying out a binomial expansion, to put each piece of information regarding A and B in parentheses so that when you get to this step to evaluate them, the exponent is applied properly to all the information in the parentheses. So here we have 5 cubed, which is 125. And then x cubed is x cubed. In our next term, we have 5 squared, which is 25, and then x to the power of 2 is x squared. In our next term, we have 5x to the 1, which just is 5x, and then here it's just 1. I'm not going to put it in, it's just 1. So now we have our a's done. Now we have to take a look at our b's. In the first term, the b isn't there, or it's 1. Again, I'm not going to write it in. In our next term, we have -1 to the first power, which is -1. In this third term, we have -1 squared. -1 times -1 is +1. And last but not least, in this last term, we have -1 to the third power, which is -1. So now we have evaluated our coefficients, our A and our B terms. The last step is to multiply what we have left after we've done the multiplications, the evaluation of the powers. So in this first term here, we have 1 times 125 x cubed. So that's 125 x cubed. Remember, this first term, the binomial coefficient will always be 1, so this multiplication will be very straightforward. In our next term, we have 3 times 25x squared, which is going to be 75x squared. And now we have a -1. So this is not an addition. This is now going to be -75 squared. Moving on to the next term, we have 3 times 5x, which is 15x, times 1. So this is 15x. And last but not least, we have 1 times -1, which is -1. So again, as I said, the binomial expansion is full of patterns. If we look here, when we have a negative for our b, the pattern is always going to be that our signs will alternate between positive and negative. And that's what we have here. Positive, negative, positive, negative. And if our expansion continued, that pattern would also continue. So that's an example of a binomial expansion.